friends, so today we are starting Unit 2, and Unit 2 focuses all on exponential functions and logarithms. So we are going to jump right into it, and today we're going to be talking about exponential functions. So the parent function, or the parent form of an exponential function, is going to be y equals a times b raised to the x power. So that's just going to be the parent function, and you're going to have to plug in numbers for a and b. So the way that you get the a and b values is a is going to represent your initial amount or your initial value. And so that is just going to be the amount that you have in the beginning. So a lot of times these are going to be talking about money in a bank account gaining interest, or it's talking about a population that's declining or something like that. And so the a value is always just going to be however much you had at the very beginning. And then b is going to represent your growth or decay factor. And so what that means is how quickly something is growing or declining. So for exponential growth, that b value is always going to be greater than 1. And with exponential decay, the b value is always going to be less than 1. So that's how you tell, looking at a function, whether you have growth or decay. So with growth, b is always going to equal 1 plus the rate that you're growing. And so I'm going to write 1 plus r, and I'm going to put in parentheses that r is representing the rate that you're growing, or the rate that whatever you have in the equation is growing, not necessarily you personally. And then for exponential decay, the b value is going to equal 1 minus the rate of decay. And so that's how the equations are going to be set up, and we're going to do a couple of examples of what that looks like. But then I also just want to show you what each of these will look like on a graph. So I'm going to draw a couple of x and y axes. And then this one, I'm going to show you what exponential growth looks like on a graph. And this one, I'm going to show you what exponential decay looks like on a graph. So with exponential growth, it means that you started out with some small amount, or it doesn't have to be a small amount, but either way, you started off with some amount, and then it just starts growing and going up really, really quickly. So that's what exponential growth looks like. Decay is going to be kind of the opposite. It's you started off with some high amount, but then it's getting smaller quickly. So that's what exponential decay looks like. So if you see either of these shapes on a graph, it's probably dealing with exponential growth and decay. So if you haven't already, please take a second to jot down just this general information, especially the parent function and what it means and stuff like that, because that's going to be super important for some of the examples that we're doing in a minute. But first, we're going to do these examples. So it's asking you, without graphing, to determine whether each of these equations is exponential growth or decay. So to do that, you're going to have to look at the b value in each of these. So in the first one, b is less than 1. And if it's less than 1, then you automatically know that it's exponential decay, because it's whatever you have is going to be getting smaller. The second one, b is 5. So 5 is definitely greater than 1. So in that case, that's going to be exponential growth, because it's going to be getting bigger. And then in the third one, 1/2 is going to be less than 1. So that is also going to be decay. So that's just how you tell, looking at the equation, whether you're dealing with growth or decay. And so the last thing that I want to do is actually solve out some of these problems. So starting with number 1, it's telling you to write an exponential function to model each situation, and then find the amount after the specified time. So the time in these scenarios, that's going to be that's going to be X. Like the time is the variable in these scenarios. So if you want to go back to your first set of notes and stuff like that, just make a note that X is representing time. So then I'm going to come back to my example here, and I need to start trying to figure out like what all of the information in this example means. So I have a tree that's 3 feet tall, and it's growing at 8% each year. And you want to know how tall the tree will be after 14 years. So I'm just going to write down the information that I have. So it's 3 feet tall, and that's like the starting height. So that means that's going to be my A value. So A is 3 feet. And then it's growing, so B is going to be 1 plus the rate that it's growing at. But then for the rate, it gives you that it's 8%. So something I need you to definitely make a note of is you always have to change the percent to a decimal. So change percent to decimal. And then the way that you do that is if it's just a whole number, that means that currently the decimal point would be located like after the number. And whenever you're changing it to a decimal, you always move the decimal point 2 spaces to the left. So instead of 8%, you would have 0.08. So B is going to be 1 plus 0.08. So then I'm going to write that here. 1 plus 0.08 is going to just be 1.08. And then the time is 14 years. So that's going to be our X is 14. So then coming down here to write it all together, first it just wants me to write an exponential function. So I'm not going to actually plug anything in for X yet. I'm just going to write Y equals A, which is my initial height, which was 3 feet, times B, which was 1.08, and then to the X power. And so then at that point, I'm going to actually plug in my 14 years for X and find out how tall that tree was after 14 years. So that's going to be 3 times 1.08 to the 14th power. So then you're going to need some sort of calculator to solve this. I have a little calculator emulator that I've downloaded that I'm hoping will work for these videos. So my equation was 3 times 1.08, and then it was raised to the 14th power. And so then whenever I type that into the calculator, I end up getting 8.81. So that would be the height of the tree after 14 years. It would be 8.81 feet tall. So that's example 1. And then I want to go ahead and try to do example 2. So this one is the price of a new home is $126,000. So that's the new home, that's the very beginning. So A is going to be $126,000. The value of the home appreciates. Appreciates means growth. So if it says appreciates with an A, then it's growth. If it says depreciates with a D, then it would be decay. So like depreciates, decay. So that's just something to make a note of. So the value of the home appreciates 2% each year. So that means B is going to be 1 plus, and then 2% is going to change to 0.02. So 1 plus 0.02. And then the time, or the X value that we're going to be using, is how much will a home be worth in 10 years. So X is going to be 10. So then first, just to write out my equation, I'm going to have Y equals the initial amount, which was $126,000, times the growth or decay factor. So I have B is 1 plus 0.02, so that's just going to be 1.02. and then raised to the x value. So then if I actually plug in my x, which is 10 years, then I would have 126,000 times 1.02 raised to the 10th power. And then that's what I would type into my calculator. So I would have 126,000 times 1.02 and then raised to the 10th power. And then after that 10 years, the home would be worth $153,593.30 about. So let's see if I can remember all that. 153,593. And 30 cents. So that would be the new value of the home after 10 years. And then we have one more example here, number 3. So a motorcycle purchase for $9,000 today, so that's my A value, is going to be worth 6% less each year. So with less, that means that it's exponential decay this time. So our B value is going to be 1 minus 6%, and as a decimal, that would be 0.06. So writing that out as an equation, we would have y equals our initial amount, which was 9,000, times, and then it's 1 minus 0.06, that would be 0.94, and then raised to the x power. If you weren't sure about the 1 minus 0.06, just type that into the calculator. I know that a lot of times with decimals that can get confusing, but that is going to be the 0.94. And then the question is asking what you can expect to sell the motorcycle for after 5 years. So that's where 5 is your time, so that's what you're going to plug in for x. So you would have to solve that out. It would be 9,000 times 0.94 and then raised to the 5th power because it's after 5 years. So then to type all of that in, it would be 9,000 times 0.94 and then raised to the 5th power. So you could sell your motorcycle for about $6,605.14. And then if you weren't entirely sure about that, like 1 minus 6% thing, then you could, instead of actually like subtracting it out, I just want to show you that you can do this. You could type in 9,000 times 1 minus 0.06 and then raise that to the 5th power, and you'll get the same thing. So it just depends on how much you want to simplify it down before you type it into the calculator. But either way, you get $6,605.14. And that pretty much sums up how you're going to do these growth and decay word problems. I will say pretty much all of them are going to be word problems, which I know some of you don't like, but there's not really going to be a scenario where it just gives you an equation and tells you to work it out with growth and decay, just because there's not really much to work out other than just typing it into the calculator. So if you have any questions on this, please just let me know. And also, if you need a calculator from the school, you need to let me know as soon as possible. I posted some resources on Google Classroom where you can download different calculator apps, just like the one that I'm using here. But I know that like the one that I have, you can see at the top it says trial version. So like even I'm only using a free trial for right now. But we're gonna see if we can make it, and just let me know if you do need an actual physical calculator to borrow from the school, or if you're having any trouble getting any of those apps. Other than that, let me know if you have any questions on growth and decay, and have a good rest of your day.